Okay, this is another pulse generator that we're going to construct from simple RC components, resistors and capacitor. Okay, so let's just start from scratch. We're going to place component. We are going to need some power supply, so let's get the sources and digital sources. No, power sources. Let's get VCC. VCC, click OK. Place it right here, and it shows us it has 5 volts. I'm going to use the wheelie on the mouse and just move that little 5 volts right there, so it just okay here. Click on that and use the arrow keys. Right, so we have our VCC. We will need a couple of resistors, one capacitor, and one probe just to indicate. Oh, push button. We'll need push button here as well. So let's get the push button. Place component. Let's just clear everything here and go back to the main all groups. From the groups, all groups for the components, and over here we can just type in the search window right here, push button for PB, for push button PB, and we have the choices of different push buttons we can use. Push button normally open, that's the one we want. Click OK, place it here for now. Excuse me. We will need a couple of resistors. Clear the search window, and resistors is going to be in a basics group. Basic. Okay, now resistor. There is a resistor, and right now it's just one resistor, and we're going to put another resistor. And we will need a capacitor, so it's just from the basic components we can choose capacitor, and we can just place it right here. Now what else do we need? We will always need a ground, so it's going to be from sources. Oh, look at that, it's just right here. Click, we do have a ground, and might as well get a probe. So probe is under indicators, and here's a probe. I like the red one, kind of looks nice, shows up nice on the monitor. Okay, close the component placement window. Okay, let's just put the VCC somewhere here. We will need a push button somewhere, and I'm going to double click and get rid of all the display values. We don't need to see them display. Yeah. Click here under the manual choice of what needs to be displayed, and I just click everything off just to get a nice clean switch. Resistor. First resistor we're going to use 10 kilo. So let's get the value of 10 kilo. 10 kilo, or you can just put 10,000, same thing. So 1000 ohms, or we can just put 10 kilo. It's the same thing. It just looks better. Double click again. What do we want to show? What do we want to not show? Display. Here we just want to don't show values, might as well, and click everything off. All right, here now, and I'm going to, you know what, I'm just going to rotate that. So I have this component selected. Control R. Hold Control, press the letter R to rotate that. And another one. Let's get the value of this one. We can get 470 ohms. 470 ohms. And let's see the display. Just show the values, and everything else can be not displayed. And then again, are we going to? Yes, we're going to rotate that. Control R for rotating it. So we have those placed. 1 microfarad. Yeah, this 1 microfarad will work, but I'm just going to increase the value to 10 microfarads. So here, 10 microfarads. And again, double click, and let's just label, show values. Yeah, everything else can disappear. Right, so let's start doing some connections. So first what we're going to do is we're going to place the ground on the bottom, place the components in approximate locations, and we are going to go from the VCC right to the push button. From the push button we're going to go to the capacitor. From the capacitor we're going to go to the resistor. From the let's just place it nice and pretty, and from the resistor we're going to go right to the ground, and we can just condense things a little bit so they're not as spread. Yeah. Alright, that's a little bit better. And what else can we do? Alright, so what we're going to do, if when we press this button, the capacitor is going to start charging, which means it's going to act as a short circuit, and it's going to make current flow through the resistor, and of course it's going to create a voltage spike across the resistor. So that is going to give us a pulse. Actually, you know what? This resistor, let's get a different resistor here. Switch them around. Let's put the 10 kilo here. You can play with the values later on, calculate the timing constants and whatnot. Right, so that's going to create a huge spike, pretty much almost 5 volts spike, and that's what's going to what we want. Now we're just going to provide a little bit of a discharge path for the capacitor, and you know what, here, see how condensed these things are. So I'm going to click somewhere else and click just on the value. I can't click on the value and move it to the other side. Or you can also, to be more precise in a placement, you can just use the arrow keys. And now when you click on this, it is going to move the whole thing. Alright, now what else? Well, of course we need the ground, so instead of placing another one, we can just copy this ground. So click, right click, copy, right click, paste it somewhere here, align that, and we're going to place that here. So what's going to happen when we push the button, the voltage is going to occur. So this resistor is going to steal some of that current, but that's okay. But it's going to produce enough, the system is going to produce enough current to charge this capacitor through this resistor, and once we release the switch, the capacitor is going to discharge itself through this resistor. So well, we have a happy situation here. Grab the probe just to show the indication of what's happening, and let's just get rid of everything that is displayed, because we don't want to have a pollution of labeling going around. Alright, connect the probe, click and click. Okay, good. Let's see what happens. Is the LED going to blink? This is just a probe that is characteristic to the multi-sim. Of course, in reality, you would create, you would connect an LED connected through a resistor to a ground. Okay. All right. Start the simulation, and let's do some button pushing and see if we get the LED to blink. Now, you can use keys, keyboard keys, for most of the parts, or like switches. This one, if you use, because all right, it is. You know, but okay, I'm gonna stop the simulation, double click, label, there's my value. All right, here, key space for toggle, it says space, so that means if you press space, you're going to operate that switch. Look what happens. If I press space, this thing just stays there. All right, that's, I wish Multisim would take care of that. It's supposed to be a push button switch, so it's supposed to be momentary, so you have to use your mouse to bring it back to where it was. If you use mouse and put your mouse over the push button, and if you click once, it's going to push and spring load right back. So that's the idea of a momentary push button switch. So space bar, yeah, it looks like you can operate it, but it just doesn't work the way we want. Or you can just close it for good if you want. Maybe that's the aim of the multi-sim people when they were doing the programming here. All right, start simulating. Press run, which is this one here, and see if we can get LED blink. Oh wow, see? Now what we can do, we can just do one more thing. I'm going to stop simulation, call up the Tektronix oscilloscope, which is the ones pretty much the same one that we have in our labs. So Tektronix, where is the Tektronix? There it goes. Here's the Tektronix oscilloscope. Click on that, bring it somewhere here, might as well. And right away I'm going to connect the ground to ground. So okay, we have the simulation stop, so that's good. Click on that, copy, and right click, paste. I'm just going to connect the ground right to the ground terminal of the oscilloscope, and channel 1 I'm going to connect right to, let's just give it a little bit, yeah, things are getting a little bit messy. Alright, that's good. And channel 1 we're going to connect right to the right across the resistor. Yeah. Now we're going to call up the screen for the oscilloscope, so double click on that, and look at that, the whole oscilloscope appears on the screen. Okay, now we're going to turn it on. What do we want? We're trying to catch the pulse. So I'm not sure if you remember from other video when we were doing the other pulse generator, how we were catching the pulse. Let's just catch a single sequence. So here is the sequence of events that we're going to do. First, you gotta turn this thing on. All right, now first thing we're going to take care of is that we're going to have to set the trigger to the normal mode, not automatic mode. So here's the trigger menu button, and it's going to make this soft menu appear as a trigger menu. So trigger menu, there we go. And mode, we have to select it to a normal. It just toggles the switch. It's a soft button, it just toggles. We got a nice rain outside, and I have the door open. Beautiful summer rain. Okay, now I wonder if you hear it. So we have the trigger normal. Then the next thing, we're going to select the beginning of the sequence, not in the middle of the screen. We want the beginning of the sequence. We want the scope to register right somewhere at the beginning of the display. So here is the position for the trigger. Where is the position of the trigger? Here is the position for the trigger. Is that it? Yeah, there we go. And you just bring it right there. Okay. Now, the next thing we're going to take care of is we don't want any false triggering happening. So we're going to raise the threshold level for the scope to start registering our signal, because if we don't set the threshold level, we are just going to end up the first time any kind of noise appears in the system, it is going to catch that, and that's it. The single shot is going to be shot. All right. So let's just set this. Here's the channel 1 threshold level. So where's the level? Trigger level, right here. So this number is going to change. All right, 10 millivolts is good. All right. So it's going to ignore anything below 10 millivolts. And of course, if you're doing other experiments, you might want to set it to whatever you need. Okay, so now the other thing is this is our 0 reference, and we know that this pulse is going to go from 0 to 5 volts. So let's just bring this thing here, this reference of 0, this, excuse me, 0 reference, down somewhere to maybe to the second division from the bottom. Okay, so can we do this? Yes, we can. We're going to position channel 1 right here. So our pulse is going to look something like that. Okay, now we're going to leave the time division, time per division. We're going to leave it alone for now. We can play with that later after we catch the pulse. Is there anything else that we need to adjust? That's pretty much it, and all we have to do is press the button excuse me, that says single sequence. Single sequence that means we're going to put the scope into a listening mode, and when some pulse happens, it is going to just register and freeze it for us. Okay, so I'm going to press it right now. Click. Okay, and we're going to start the simulation. Let's press the button and see what happens. Oh, look at that. We just have a nice pulse registered. Now, what we can do, since we have this thing frozen now, we can bring that scope view onto the into the middle of the screen, and now we can play with the time per division. So we could just display a different view. See, this time per division changes. The pulse doesn't change, it's just the way it's displayed is being changed. So let's just get this thing to some sort of a comfortable level here. All right, now here's our 0 reference, that's where we set it, and the pulse was being captured from the beginning of the screen. So we can still position it left or right, just so it aligns. We can align that with the grid on the screen, so it's going to be easier for us to measure things. All right, so channel 1 shows 1 volt per division. Here's our 0 reference. See how high our pulse is, how tall. 1, 2, 3, 4, and 5. Okay, so 5 volts. There you go. Here is 5 volts. How long is our pulse? How long does it last? Our pulse lasts, here is the 5 microseconds per division. 500 microseconds per division. 1, 2, 3, 4.8 microsec times 500. So we could do the calculation, or what we could do is we could hit the measure button as our convenience. So hit the measure button and bring the cursors. Right, again, measure, call up the cursors. All right, now once we got the cursor menu, the cursor type, we're going to select the cursor type because we want to be able to, this scope needs us to tell it what we want to measure. So let's toggle that cursor type to a time, because we want to measure time from left to right, how long the pulse lasts. All right, so here's the toggle button. Voltage, now we can also measure the voltage. It's going to give us the voltage measurement. We toggle again. Oh, here's the time. Now these two lit up, so that means these are the two controls. This is going to be the left cursor, this is going to be the right cursor. Just let me show you what I mean. See, we bring the left cursor over here, and over here we bring the right cursor. All right, so let's position the left cursor to the beginning of the pulse. There you go, approximately somewhere here. Let's position the right cursor to the end of the pulse, which is going to be somewhere approximately here. What do we have? The cursor 1 and cursor 2. See now? Now, of course, cursor 1 says that's 0 seconds, because that's where our beginning, our reference of, that's when we began to capture the pulse. Right? We just positioned everything left or right, okay? But this is where our beginning was. So the cursor is going to reference itself to where we set this pulse to start appearing on the screen. All right, so it is going to show up as 0 reference, cursor 1. Cursor 2 stands at 2.37 milliseconds, which makes sense. All right. 500 microseconds, so 500 microseconds times 2 is going to give us 1 millisecond, right? So 1, 2, here's 1 millisecond, 1, 2, here's another millisecond, and then there's a fraction of a millisecond, 2.37 milliseconds. That's what the other cursor stands. And here's the delta measurement, which is the change of the difference between these two cursors, and it shows us 2.37 milliseconds, of course, because cursor 1 sits at 0, cursor 2 sits at 2.37, so 2.37 minus 0, it is going to give us the, of course, it is going to give us the time, or the time from here to here. Now, the frequency is not going to matter because we are not having anything that is repeating, but it's going to show something. If that was the whole, if that was the whole, the period divided by period 1 over the period is going to give us the frequency, but we're not paying attention to that right now because we just have one single pulse. So that's how we generate a pulse. Okay, now we can we do it again? Sure we can. Now we have this references set up here. the voltage reference is set up here. Let's see if the pulse looks different. So you know what, all you have to do is just press the single sequence again. Simulation is still going. Somehow, sometimes it works, sometimes it doesn't, but I think this time is going to work. So press the, and I'm talking about the multi-sim simulation, not the real life. Single shot or single sequence, press it. Screen gets clear, the scope is in the listening mode. Anything comes up, it's going to register it. Press the button again. Alright, look at this. Now we have something else. Right? What do we have? There we go. Now we have a different pulse because the capacitor was initially discharged. 1, 2, 3, 4, 5, but the pulse looks different. Okay, it just looks like that. It's like a spike. So let's bring up the cursor to here, and before the pulse reaches 5 volts, and let's see here. Let's bring the other cursor here. From complete 0 to complete 0, it takes about 19 microseconds. Yeah, almost 20 microseconds. But here, where I'm going to bring it to where it goes from 0 to high, and it takes from complete 0 to complete high. You see the cursor 1 is at the negative value. That's okay. Cursor 2 is going to be at some value, and what we're interested is how much time does it take to move from cursor 1 to cursor 2, and that's a very convenient way of showing us. So it's 9.5 microseconds from here to here. Okay, now if you can play with different values of the resistors and capacitor and get different values, but you know what, this is going to be good enough for our pulse that we're going to set to our JK flip-flop that we're going to build next.